Okay, in this video we're going to look at how to differentiate sin x from first principles. This is basically an HL topic. It's not an SL topic, but it helps your understanding at SL. The reason it's not an SL topic is we're going to rely on a identity that you don't know at SL. Okay, so we're going to start off with y equals sin x, and the way I like to think about doing differentiation from first principles is to have an x1 coordinate, which is always x, an x2 coordinate, which is x plus h, the y coordinate, which is from here, and the y2 coordinate, which is going to be sine x plus h, because this is what the x2 coordinate is. And to find the gradient, if I reveal this, this is my gradient function here. So I'm going to substitute each of these values in to the equation like that. This is the gradient function, or m. Here's the first one, y2 minus y1, x2 there minus x1. So I've filled all that in, and that's where I've got. Now from here, to simplify this, well, the bottom simplifies quite easy. I can easily do x and then take away x on the bottom, no problem at all. But the top, this is where the identity that you don't know at SL. I'm going to use this identity. It's a higher level identity, and it's for compound trig identities. So have a look at that. What I'm going to do is I'm going to take the first bracket and I'm going to rewrite it in a long way like that. And that's this one here. So it's sine x cos h plus sine h cos x, and then I've got this sine x at the bottom, and I've simplified the bottom there. Now on the next slide I'm going to take that. It's exactly the same here, I haven't done anything with it. And now what I'm going to do is I'm going to put the sine x's together. So all I've done is, if you like, I've moved that across, so I've got them next to each other. And this bit here, this bit right here, I can now factorize. So that's what I've done there. I've factorized taken the sine x out, and I'm left with cos h minus 1 in here and sine h cos x over h here. Now what I've also done is I've split them up, so this first part here is over h and the second part is over h. When you're differentiating by first parts, you have to from first principles, you have to remember that h is going towards 0. The limit of h is 0. So I'm going to take h, limiting at 0, and I'm going to use this part here. Let me just put a box, if you like, around it, this, and I'm going to work out as h goes towards 0 what happens, and I'm going to do the same here. I'm going to take this part here, and as that goes towards 0 what happens. So this first part here, I've graphed this right here. As it goes towards 0, it is 0. And that is reflected in that. So as that first part, as h goes towards 0, we're getting 0. You can check that on a calculator, you can check it on my graph there, but we get 0. And I'm going to do the same with the second part. As that goes towards 0, we get 1. And again, I've drawn a graph of that right here. Here's the graph. As it goes towards 0, it becomes 1. So what I end up with is this part here is 0, so it completely knocks out that part because it's 0 times sine x. This thing here becomes 1, so it only leaves cosine x. So after all of that, we eventually find that dy by dx is cos x.